Welcome back at C squared. In this lesson we'll talk about circle, and you notice here we have a circle. In this picture we named the circle based on its center, so this is circle M, and you see the notation right here if you need that notation. These are three things that are important for a circle, and not only chord. A chord is the segment that has both endpoints on the circle. So if we look to this picture, AC will be a chord, this one. Diameter is the chord, so diameter is also a chord that passes through the center, so that will be DE in this case. Radius is a segment that has one endpoint at the center and the other endpoint on the circle. So we have three radius here, MD, ME, and MF. Radius is half of the diameter, I said there. So you can see it here, these two relations. Radius is half of the diameter, or vice versa backwards. Diameter is twice the radius, 2r. Let's take a look to this example. We need to name this circle first. So this is what I call circle T, because the center is T. Name the radius of the circle. So we have, and by the way, this is the plural of radius. So we have TA, we have TB, and we have TC. These are three radii of this circle. Name the chords of the circle, and we notice here DE is a chord, both endpoints on the circumference. But we have one more. The diameter itself is a chord. Just to emphasize, diameter is the longest chord, in case you need that. Name a diameter of the circle, already said, AB. Name a radius not drawn as part of diameter, so that will be TC. Let's take a look to this problem where we have three circles, MN and Y. The diameter of circle M is 40, the diameter of circle N is 100, and the diameter of circle Y is 60. We need to determine the measure of segment ON. This is the segment we need to find out, and we need to justify our answer. And if you take a look in our picture, we can notice that ON, that segment, plus MO, so this addition of two segments gives us MN. This is the segment addition postulate, in case you need it. Now let's take a look. ON is the segment we need to find the measure. MO, if you take a look to MO, this segment is the radius of circle M. So MO will be half of the diameter of circle M, and if you notice, the diameter of circle M is 40 inches. So 40 divided by 2, that will be 20 inches. Let's take a look to MN. MN is this segment, which is nothing else than the radius of circle N. So MN will be half of this 100, and that will be 50. So now let's replace this value we found in the first statement. I wrote ON, we need to find out, plus MO 20 equals MN 50. Just subtract 20 from each side, and ON will be nothing else than 30. Let's take a look to part B of this problem. Very similar. Determine the measure of NK. NK is this segment, and we notice NK plus KY is NY, the segment addition postulate, if you remember and if you need it. Okay, so now let's take a look. NK is the segment we need to find out. What about KY? KY ky, if you take a look, is the radius of circle y. So that will be half of this 60, because the diameter is 60. So it will be 30. And also ny, if you take a look, ny, what is ny? Ny is the radius of this big circle. We already found out it's the same like m, and would be 50. Okay, but let's write here 100 divided by 2 equals 50. So now we're gonna go in the first statement we wrote and replace ky with 30 and y with 50, and of course, you know, now we're gonna subtract 30 and end up with nk equals 20. On my next part of the lesson, I'm going to talk about circumference. Circumference of a circle is the distance around the circle. You need to go around the circle like this. This is the circumference. We have two formulas we can use. This one, circumference equals 2 pi r when you know the radius. And you have a second formula, circumference equals pi d when you know the diameter. So C stands for circumference. R stands for the radius, and D stands for the diameter. So again, two easy formula that I think you can remember in case you need them. Let's take a look to this example. On part A, we need to find the circumference of circle M, and we know MD is 20. But if we look to the picture, MD is 20, that is the radius. So we're going to use the first formula, 2 pi r, and we're going to replace the radius with 20, and 2 times 20 will be 40. 40 pi is the circumference of circle M. We're going to leave the answer in this form because that's what we need. Leave your answer in terms of pi. Let's take a look to part B. Part B, we need to find the circumference of this circle, circle M also, but a different circle obviously. And what is given now is DE. If you take a look, this segment DE is the diameter, and is 12, so we're gonna use the second formula, the one that says pi d. We're gonna replace d with 12, and this is the answer, 12 pi. A real life application now, where we have two tires, tires A and tires B. You notice tires A has a diameter of 32. That is the meaning of that. It's the same with this segment. Tire B has a diameter of 28 inches. So this is the diameter. We need to find out how much farther does tire A travels than tire B, and why it does travel further, because the diameter of this tire is larger. So I already said what the concept here will be circumference. So circumference of tire A will be pi times the diameter of tire A. Let me say like that. And that means in this case we have pi times 32. So it's going to be 32 pi. Okay, what about tire B? Very similar. The circumference of tire B would be pi times the diameter of tire B, which is 28 inches. So we have pi times 28, and that will be 28 pi. We need to do one more thing to answer to this question: how much farther does tire A travel than tire B? We need to do a subtraction. C sub A, the circumference of tire A minus the circumference of tire B, and that will be 32 pi minus 28 pi, and that will be 4 pi. Of course, if you need to evaluate this, use a calculator. On this problem, we go backwards and we have a circle with the diameter of 24 inches. I'm sorry, with a circumference of 24 inches. And we need to find the diameter. So, if you remember, the circumference, it's pi d. So we're gonna replace in this first statement I put pi d equals 24, and we need to solve this equation for d. And for solving for d, we need to divide by pi because we have pi times d. So these two guys cancel out. Don't forget to do that on the other side. And this is the exact answer for our problem. The diameter of this circle is 24 over pi. If you need to evaluate, just use a calculator and put it in. Sometimes you're going to have what we call circumscribed or inscribed circle, and this term can be here also about any other shape like circumscribed triangle, inscribed triangle, for example. So what does it mean? Circum means go around. Okay, so if you take a look, this is the both problem we have here are about circumscribed circle. And we have here EF equals 9, this one is 9, and FG equals 12. And we need to find the circumference of this circle T. For that reason, we need to find the radius or the diameter of this circle T. This segment you see here, TE is the radius and EG is the diameter, which is part of this right triangle. 9, 12, you see it's a right angle here. Can we find this? And I'm going to call it X to make the things easier. And we can use Pythagorean theorem, a squared plus b squared equals c squared. So we're going to have 9 squared plus 12 squared equals x squared. So I use Pythagorean theorem, like I said. 9 squared is 81. So this is 9. 81 plus 144 equals x squared. And that will be 225 equals x squared. So x will be square root of 225. Don't need to put plus and minuses. We talk about the length of a segment, and that will be 15. Of course, this x is nothing else than the diameter of this circle. The diameter is 15, so we can find out the circumference, which is going to be pi times d. So it's going to be pi times 15. So the final answer is 15 pi. Very important, if you remember, this is a special, this is what we call a Pythagorean triple, 9, 12, and 15. If you remember that, that will be even faster. Let's take a look to the second problem, very similar. We have a circumscribed circle, like I said, circle P, and we have a triangle inscribed in this circle. And we see here AH and AV are the same, congruent, that's what it says. And AV is 8 square root of 2. So that means this is 8 square root of 2 here. Okay, and this one, I will use the shortcut here. It's good to use a shortcut. You can use Pythagorean theorem and check me. But this is a very special triangle is an isosceles right triangle. This is going to be 45. This is going to be 45. And since the leg is 8 square root of 2, the legs, in fact, both of them, because they are congruent, this is going to be 8 square root of 2 times square root of 2. So I use a special right triangle, 45, 45, 90. If you need to review this triangle, you can find it on my YouTube channel. So how much is 8 square root of 2 times square root of 2? That will be 8 times 2, and that will be 16. So now we know the diameter. The diameter of this circle P is 16. So the circumference will be pi times d, the same formula like we used in the previous one. So it will be pi times 16, and that will be 16 pi. So again, here it's very useful if you remember this 45, 45, 90 triangle. Other than that, you can use Pythagorean theorem like I did on the first example and find the diameter. Here we have two more problems, and if you notice, that's what I mean by an inscribed circle. The circle is inside in this case. Here we have the same thing like in the previous problem, an inscribed quadrilateral. But let's take a look to part A. In this one we know GF, which is this segment, is 12. Ladies and gentlemen, you notice this segment is the same with this segment, which is the diameter. So in fact this problem is very simple. The diameter is 12. The circumference is going to be pi times d, the same formula, so it's going to be pi times 12, so it's going to be 12 pi. Let's take a look to part B. In part B we have this quadrilateral inscribed, or the circle is circumscribed, and we know HC it's 3 and AC is 3 square root of 3. You notice this is going to be also 90-degree angles. These two angles are the same. This is the diameter. So we have these two triangles. We can use one of them. Let's say the top one, since I already put the numbers there. This is 3, this is 3 square root of 3, I apologize. How are we going to find this x? Again, Pythagorean theorem. Some of you may recognize this triangle, but let's use Pythagorean theorem here. And we have 3 square plus 3 square root of 3 square. So you see I use the parentheses here, equals x squared. 3 squared is 9 plus, now we have this 3 square root of 3 squared. If you need, you can do this multiplication, multiply to irrational number, if you want to call them like that. And we have 9, 3 times 3 is 9, these two. And then we have square root of 3 times square root of 3, that will be 3, that will be 27. 9 plus 27 equals x squared. 9 plus 27 will be 36, and that will be x squared. So x will be square root of 36, which is nothing else than 6. So ladies and gentlemen, the diameter of this circle is 6. And by the way, this is another special triangle if you want, 30, 60, 90, if you remember, that will be good. And the hypotenuse is twice the shorter leg. That is the shortest way to do it. Circumference is pi times d. Let's go back to this circumference. So we're going to have pi times 6, and that will be 6 pi. And my last example in this lesson will be about these two triangle. You notice on the first one the circle is circumscribed, on the second one the circle is inscribed in the triangle. On both of them, the length of AB is 10. So this is 10, and in the other one it's also 10. But now I'm going to really use the shortcut because I think is the best way. This is an equilateral triangle, and if you notice, this is the height of this equilateral triangle. So that means these two pieces are the same because the height, the altitude in an equilateral triangle bisect the opposite side. So this is going to be 5 and 5. This is going to be 10. And this is a special right triangle, 30, 60, 90. So this is 5. This is 10. This is going to be 30 because this angle ACB is 60 and this is the angle bisector. So this angle is 30. This will be 60. And now we can find very fast the length of this guy. Okay, that will be 5 square root of 3. Okay, let me be sure we can see that. 5 square root of 3. And again, I'm gonna say I use here 30, 60, 90. It's very useful if you remember in this case. And then I'm looking for the radius. Okay, the radius, if you notice, start from this point, which is the circumcenter of this circle. So TC will be 2/3 of this 5 square root of 3. That is a property that for medians, if you remember. So in this case, we have TC equals 10 square root of 3 over 3. TC is nothing else than the radius, like I said, so we can find now the circumference. Circumference will be 2 pi r. We're gonna replace it with this radius, 10 square root of 3 over 3. There is no simplification here possible. We're gonna just multiply, then we have 2 times 10, 20 pi square root of 3 over 3. This is the circumference of this circle where the triangle ABC is inscribed. Let's take a look to the second problem. Second problem very similar, however different. If you take a look, this is the radius of this circle, one of the radii, and it's part of this median, of course, very similar with the other problem, right? And this is going to be 5. This is going to be 5. The sides, this side is going to be 10, so a very similar approach. It's going to be just some people may say minor. I think it's a major difference. This is 5, this is 10, and obviously this is going to be 5 square root of 3, because I'm going to use again the 30, 60, 90 rule. But now if you take a look, this segment, which starts from this circumcenter and goes here, the radius, this radius here is 1/3 of the median. So R will be 1/3 of 5 square root of 3. So that will be 5 square root of 3 over 3. So now we can find the circumference, 2 pi r, the same formula. So we're going to have in this case 2 pi times 5 square root of 3 over 3. So the circumference of this circle will be 10 pi square root of 3 over 3. You notice the circumference of the inscribed circle, the circle inside, it's half of the circumference of the circumscribed circle, the one outside. If you enjoyed this video clip, don't forget to click the like button and come back. and C squared for more help. Thank you.